So welcome all to Dr. MDS Academy. Here I am presenting small animations, uh, detailed visualization and explains how the buckling happens in column. So in left side here we have different four cases. One is the both and fixed, okay, which is given as a critical load values P critical is equal to pi square EI upon L square. See, the maximum P critical load is happens for the P critical both end fixed, and another for this case here one end fixed and another end free. Minimum value of P critical you will get because it is divided by 4, and this was for the maximum case multiplication of 4. In the below real picture you will be finding. So these are the 1 2 3 4 these are the different columns, and the horizontal sections here, horizontal sections is called as a beam. Okay, so this was the horizontal section, okay, called as a beam, and this vertical is known as a this vertical all are known as columns. Okay, so mainly we are talking about here in animation columns. So let's come to our animation videos. Pause the videos. Okay, so we have different four cases: pinned, so pinned, fixed end, one end fixed, another end free, another third one is the fixed, both end fixed, and fixed pinned. Fixed, one bottom is the fixed and upper one is the pinned or hinged. Okay, see, since P critical is equal to pi square EI upon L square, so as we are decreasing the E value, see the real value of P critical you will be getting data here. So as we are decreasing the E value, see the P critical load is decreasing because directly proportional P critical and E. Now as we are increasing the E value, okay, so in the bottom right side you will be finding now it is in a stable, now approaching and buckled. See, this is the buckled portions. In the last moment of the video you will be getting. Okay, see, now it is stable, now approaching buckled, now completely buckled. Okay, for the case of fixed pin. Now as you are increasing the E value, see the P critical load is jumping to the higher value. Okay, so let's keep values P critical somewhere here 118 dPa. So as now next is the I. This I and P critical is similarly directly proportional. As you are decreasing the I value, see what is happening. P critical is decreasing. Okay, now increase this I value. See the P critical load will also rise to the higher level. Okay, now in the similar fashion, length of the column, as we are decreasing the length of the column, since P critical and I, what we had seen inversely proportional here in the formula. So as we are decreasing the length value, see what is happening, the P critical is increasing. Now just increase the length of the column. What is happening, P critical load is decreasing. Okay, now decrease the L value, P critical value is increasing. Okay, so similarly for the different cases we can check if the end conditions are pinned. Okay, so here you can see if the end conditions are here, the end conditions for the two cases I am talking about, both end fixed means what, maximum P critical you will be getting. So this is the case, both end fixed. So how much value you are getting for both entries? 4 to 81. Okay. Now for what case we get minimum peak critical? For this divided by 4. One end fixed and another in free. Fixed and another end is free. Fixed and this is the case. So currently the maximum peak critical for this case fixed is 4 to 81. So for this case we are getting 267. So minimum peak critical you will be getting for this case and maximum for this case. So you can check it for the different cases here. Currently the pinned we are having. Let's keep the length small. For this case pinned, see how the now buckled. Now let's switch to the fixed free end. See the complete cycle. Now it is buckled with a smaller value. Now third case is fixed. See how the now buckled. Another case is the fixed pin. Now it is a stable. Now approaching buckled. Okay. So as usual, let's say I have increased the L value here up to here. So see the for the different cases I have kept E and I same for all the cases. Now let's switch to the fixed free. Okay, now fixed. Now third is the fixed, fourth one is the fixed pin. Now I'm just increasing the E and I. Okay. So let's decrease length. Check the different cases. So this shows how different variables affecting the buckling of the column. Now the next one is fixed. See. Okay, very large buckling techniques. Fixed pin, fourth case. So that's all about the buckling of column.